So in 1.3, we're going to start off by talking about slope. So slope is given the symbol lowercase m and given 2 points, x1 and y1 and x2 and y2, our slope m is given by y2 minus y1 all over x2 minus x1. We also will talk about slope in terms of rise divided by run, or the change in y divided by the change in x. So we're going to use some abbreviations when it comes to slope. One of them is it looks like a triangle, but it is actually a Greek letter. Specifically, it is the Greek letter capital delta. And delta stands for, or is read as, the change in. So we'll notice then if delta is the change in, that's the same as what we have right here. So we could rewrite that as the change in y over the change in x. So when we see the Greek letter capital delta, or that triangle, it means the change in. All right. So the first thing we want to do is determine the slope of the line that contains the following points. So this is going to be an application of our slope formula. So we had that m was equal to y2 minus y1 all over x2 minus x1. So this is very similar to what we were doing in 1.1. We're going to just put the corresponding x and y values into our formula. So y2 is going to be negative 5 minus y1 is negative 1 over x2, which is negative 3, minus 8. So then we get minus minus makes it a plus, and that gives us negative 5 plus 1 is negative 4. Over negative 3 minus 8 is negative 11, which a negative divided by a negative gives us a positive. And as I've mentioned a few times, there is no reason to do any of this arithmetic by hand. You could have just done this all directly on your calculator by going alpha y equals and just typing it in exactly as it was. Negative 5 minus a negative 1 over negative 3 minus 8. And our calculator agrees with my computation that we should have gotten m was 4/11. So for a lot of this arithmetic, I know you guys know how to add, subtract, divide, and multiply. We did all of that in a previous class. We have this calculator, and let's make sure that we're using it to make our lives as efficient as possible. All right, and that said, it's now your turn to take a look at this U-try, but before I turn you loose to work on it, our ordered pairs were given in function notation. So remember that this is an input and that this is the output. All right, so let's go ahead and, all right. So to find the slope, we need to use the two ordered pairs. So we have our inputs and our outputs. So we have -4 and 7 and 6 and 7. So then our slope would be 7 minus 7 over 6 minus a -4, which is 0 over 10, which would give us 0. And we note that if we look at our two outputs, 7 and 7, the change was 0, which is exactly what we had here. Our delta y is 0. The distance between -4 and 6 is 10 units. So that was our change in x as we went from -4 to 6. All right, so let's take a look at our next example. So given a graph, we also want to be able to determine slope. So using our definition that it's the change in y over the change in x, we can pick any 2 points that we can read off our graph. So I'm going to pick that point, and I'm going to pick this point. And if I do something like this, if I go this direction, I would count off 1, 2, 3, 4, 5. So my change in x would be 5 units. And then I would go 1, 2. But since I went down in the y direction is negative, that would make my delta y -2. So then my slope would be the change in y over the change in x, which is -2 over 5, or -2/5. It's worth noting that if I were to pick some other points, say this point and say this point, what if I were to draw this and go in this direction? So then this time I would go up 1, 2, 3, 4, 5, 6. So my change in y would be +6. But since I'm going to the left now, my change in x would be negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my change in x would be -15. So then my slope, m, would be my change in y divided by my change in x, which is +6 over -15. Each of those are divisible by 3, so then that would be 2 over 5, and it would be negative. So notice, whichever points I pick, I will always end up with the same slope. So the key thing we have to remember is that when we're talking about x's, right is positive and left is negative. And when we're talking about y's, up is positive and down is negative. So the next thing we want to talk about is slope-intercept form. And our slope-intercept form is y equals mx plus b, or f of x equals mx plus b. And in either case, we have our b values are going to be the y-coordinate of the y-intercept. And as we talked about before, our m is going to be our slope, or our rate of change. And so this is something that we want to keep a lookout for. If we ever hear rate of change, what we're really talking about is a slope. So in our next example, it says determine the slope, if it exists, of the graph of the linear equation. So we want to compare that to y equals mx plus b. So we look at our slope, and we compare the coefficient on the x here. So we see that our m value is going to be 6/7. So that would be the slope of our line. We weren't asked explicitly to do so, but if we were asked what was our b value, we would see that our b value would be -3. All right, we're not going to break out into rooms, but if we look at our next one, if we just eyeball our line that we have here, our slope would be -0.35, and our b value would be 4. So our next two examples that we're going to do, so example 4 and you try 4, are related. So let's take a look at example number 4. We're asked to graph the equation x equals to -6. So if we were going to make a table of values of our x's and our y's, normally we pick whatever we want. But to make that equation true, what's the only value of x I would be allowed to pick? Yeah, -6, right? Because if I picked any other value for x, I'm going to get a false statement. But if my equation is x equals -6, the value of y doesn't matter. I can pick it to be anything. If I pick 1, 5, and -3, as long as I pick x to be -6, the value of y doesn't matter in making that equation true. So if I plot these points, I go to -6 and 1, -6 and 5, and -6 and -3. And then if I connect them, I get something that looks like this. So the graph of x equals a is a vertical line with x-intercept a, 0. All right, I'm not going to break us into rooms, but I do want you to try to plot a couple of points on you try number 4 really quick. So go ahead and graph a couple of points, but this time we have y equals to 2. So if we were to make our table of values this time, we have our x, y, but since our equation is y equals 2, the only thing we're allowed to have for y is 2. So in this case, the values we pick for x don't matter. So if I go to -3 and +2, 0 and 2, and 4 and 2, and we connect the dots, we get a line that looks like this. So once again, the graph of y equals b is a horizontal line with y-intercept 0, comma, b. All right, so now for each of these, we want to determine the slope. So if I look at my vertical line and I analyze it up here, what is my change in x going to be on a vertical line? Well, does my x value ever change?
No.
No, my x value is always -6. So then it doesn't really matter what delta y is. So if I have delta y divided by delta x, I'm going to have delta y divided by 0, and that's going to be undefined. So vertical lines have undefined slope. In a similar fashion here, and we did an example earlier, well, what's my change in y going to be on a horizontal line? Well, this time, my change in y is going to be 0. So if I look at my slope, my change in y over my change in x is going to be 0 divided by delta x, and 0 divided by anything is 0. So to summarize, the slope of a vertical line is undefined, the slope of a horizontal line is 0. So for those, we don't need to do computations. We should just know that the slope of a vertical line is undefined and the slope of a horizontal line is 0. All right, we are going to jump to example number 6. But before we do, we need a definition of the average rate of change. So rate of change is a slope, but now we want to talk about an average rate of change. So we'll draw a picture to help motivate this. So let's imagine I have some function, f of x, that looks like this, and I want to find its average rate of change. Well, for things that aren't lines, we don't really have a formula for slope. So the idea is if I want to find the average rate of change between 2 points, x1 and x2, I would find the slope of the line between that connects those 2 points, and that would be the average rate of change of f. So in terms of our formula then, for average rate of change, we would have our slope formula, which is f of x2 minus f of x1 all over x2 minus x1. But this is really just our slope formula that we had above. So when we say average rate of change, we are just finding the slope through 2 points. So it's really not a different formula, so don't let that bother you. And that's often one of the things that confuses people when they hear average rate of change compared to rate of change, but they're actually the same thing. So then this will give us context for our example number 6. So in 1998, the average price of a barrel of oil was $11.91. By 2013, the average price of a barrel of oil was $91.17. Find the average rate of change in the price of a barrel of oil from 1998 to 2013. So, to find the average rate of change, what do we need to know? 2 points. So we need 2 points. So we need an X and a Y that pair together. So our first one is in 1998. It pairs with $11.91. And then our next ordered pair is in 2013. That pairs with $91.17. So then we need to find the slope between those 2 points. So it's y2 minus y1. So 91.17 take away 1191 divided by 2013 take away 1998. And if we grab our calculator and we go alpha y equals, and we have 91.17 take away 11.91. Helps if you type in 11. 11.91, 2013 take away 1998. And we press enter. And we get this value. Right here. So we have 5.284, but we have something else that we should probably at least note. So in the numerator, 91.17 and $11.90 or $11.91 were in dollars, and 2013 and 1998, their units were years. So what this really tells us is that our rate of change was $5.284 per year. So the division is our per here. So when we said we found the average rate of change, we found that the price of oil changed by about $5.28 with 0.4 of a cent dollars per year. That doesn't mean that in any of those years it actually changed by that amount. That is just the average rate of change during that time. All right. So let's go to example number 8. And talk about how we're going to resolve this. And for example number 8, let's find the slope and the y-intercept of the line given by the equation 5x minus 7y is equal to 3. So the form of this line is it's said to be in standard form. For graphing, whether we're going to do it by hand or use our graphing calculator, we're always going to want to convert to slope-intercept form. So the first thing we're going to want to do is convert to slope-intercept form. So to do so, what we do is we solve for y. So in our case, we have 5x minus 7y is equal to 3. And we want to solve that equation for y, or isolate y. So the first thing we're going to do is minus 5x and minus 5x, giving us negative 7y is equal to negative 5x plus 3. And then the next thing we do is we divide by negative 7, divide by negative 7, and we divide by negative 7, giving us y equals 5 over 7x minus 3 over 7. So we want to find the slope and the y-intercept of this equation. So now we compare that to y equals mx plus b. And we see that our m value, which is our slope, is going to be 5/7. And our b value is going to be this guy here. So we get that b is equal to negative 3/7, and this is the y-coordinate of the y-intercept. So we're going to get the point 0, negative 3 over 7 for r.